Good evening, my YouTube viewers. In this particular video, we're going to perform a chi-square test of independence, and we are going to be testing ice cream preferences. So you want to test whether there is an association between gender, male and female, and preference for a new flavor of ice cream, like and disliked. The observed frequencies are given in a contingency table. Test the independence at a 5% significance level. So we've got our observed values and we've got our expected values. So in the observed values, you've got 30 men like a certain ice cream and 20 men dislike a certain ice cream, giving you a total of 50. And 25 women like a certain ice cream, but 25 women dislike a certain ice cream, giving you a total of 50. And then so you've got your total of 55 and 45 for the columns as well. And now we have the expected. So it's expected that 27.5 men like this ice cream and 22.5 men dislike it, giving you a total of 50. And for the females, 27.5 like the ice cream and 22.5 dislike the ice cream, giving you a total of 50. And again, for your columns, you have a total of 55 and 45 in your columns. So what we do is we check our alpha is 0.05 and your degree of freedom is 1, because the degree of freedom is 2 minus 1, which is 1, times 2 minus 1, which is 1. So 1 times 1 is 1. So you have 1 degree of freedom. So you've got your null hypothesis is there's no significant difference between observed and expected values. And the alternate hypothesis, which can be either described as HA or H1, means there is a significant difference between observed and expected values. So your p-value based on expected and observed values is 0.312321. And so that's a chi-square test, chi-square.test brackets GH to H9 and B8 to C9. And then another way to contact the p-value is chi-square test.RT is M6. Sorry, this is M6 right here. M6, comma, B13. Excuse me, that gives you your degree of freedom. So there's two ways that you can calculate your p-value, and they're not too dissimilar. They're very close. And so now what we do is we interpret the p-value, because if the p-value is greater than 0.05, then you're going to fail to reject the null hypothesis. But if the p-value is less than 0.05, you're going to reject the null hypothesis. And so we do an if statement. So if B19 is less than B12, that's your alpha, reject the null hypothesis. Otherwise, fail to reject the null hypothesis. So we fail to reject the null hypothesis, so that means there is no significant difference between the observed and the expected data. And what I did was I created a chart so you can see the likes and the dislikes. And according to the test that we performed, they're saying there's no difference, no significant difference between the male and the female likes and dislikes. So the next video we're going to be carrying out an ANOVA. That's an analysis of variance. And so I hope you decide to watch it.